Okay, so let's look at the two questions you sent me. Here's the first one. So it says the plane flies 1.6 hours at 150 miles an hour on a bearing of 10 degrees. So we face north and we just rotate clockwise 10 degrees. So that's where that's our starting point right here. Then it turns and flies 9.1 hours at the same speed on a bearing of 100 miles per hour. So once again, you face north and kind of rotate clockwise. How far has the plane? How far is the plane from the starting point? So we want to figure out side C right here. Okay, so if you were to look at this, if we were to kind of look at this closely, these are parallel lines right here, and this is basically a transversal cutting through it. And so this angle right here, that angle right there would also be 10 degrees because that's alternate interior angles. And then right here, we have a straight angle, right? From here to here, right? That's our straight angle. That's 180 degrees. So that means this must be 80 degrees right here. So what that tells us is that the angle altogether is a 90-degree angle. It's a right angle right there. And so really all we have to do is figure out the distance of my legs, and then we can figure out the hypotenuse by doing Pythagorean theorem. So let me grab my calculator. Okay, so on the first part of the trip, we go 1.6 hours. We're going 150 miles per hour, so I multiply that by 150. So that's going to be 240. So that's 240. And then our other leg, we fly for 9.1 hours at the same speed, so times 150. That'll give us 1365. Okay, and so then here we'll go ahead and do Pythagorean theorem to figure out side C. So C squared equals 240 squared plus 1365 squared. And then what we'll do is once we get that result, we'll square root both sides, and that'll give me side C. So I'll go ahead and put that in my calculator. So I'm going to put in the square root. Let's see. So there we are. Square root of 240 squared plus 1365 squared. Alrighty, and that should give me my result. So 1385.9, let's see, 1385.9, and that'd be miles. And I don't know, I'm not sure, I don't have it listed here, but on the question it should tell you how much to round by. It might tell you to round to the nearest mile, so then we'd round up to 86, but that's the first one. All right, the second one is it's similar, but it's a little bit more challenging. They don't give us a picture to start with, and then also they don't give us enough information to figure out both legs. So, but anyways, let's go ahead and look at this one. This one will be a little more challenging. So let's see, the bearings from A to C is south 59 degrees east, okay? And the bearings from A to B is north 83 north and then 83 degrees towards the east. The bearings from B to C are south and then 31 degrees to the west. Okay, so a plane's going to fly 250 miles per hour, and it's going to take it takes 2.8 hours to go from point A to B, and then they ask us to find the distance from A to C. Okay, so I'm going to draw this, and it probably won't be quite to scale, okay? So we'll want to keep that in mind. I'm going to do the best I can, but sometimes it just can kind of be a little challenging. So what I'm going to do here, I'm going to draw a line right here because this is kind of like my north and south line, okay? And so I'm going to go ahead and put point A, let's see, so I'm going to have to look south. Okay, I'm going to move that a little bit higher, actually. Put that up here. Okay, so I'm going to put point A right here. So that'll be my point A. So I'm supposed to look south and then go 59 degrees towards the east. So we have north and then east. south, and west, right? So I look south, and then I'm actually going to turn to the east 59 degrees. So like this angle right here will be 59 degrees. And so I'll go ahead and kind of draw it like this, okay? And that's from point A to point C. So we'll put C right there. And then let's see, then from point A to point B, I'm going to look north and go 83 degrees towards the east. So that'll be something like this. And, you know, it's not going to be perfect. But yeah, this is going to stretch out a little bit further. Okay, I'm trying to look to make sure it will look somewhat accurate. So there's where B is going to be. And then from B to C, so once again, I'll kind of put like my north and south pole right here. And so then I'm supposed to go south and then turn 31 degrees to the west. So now I'm coming back. And actually, this is not too bad of a job. And so I'm going to go ahead. It's not perfect, though, but I'm going to go ahead and label what I should know. So I should know that that right there is going to be 31 degrees, okay? The first bearing right here, this is 59 degrees. And then this one up here is going to tell me, let's see, I turned 83 degrees, so that would be 83 degrees right there. And then we'll look at angle C a little closer in a second. Let's see. So what that does tell me is I know the angle right here, because this is a straight angle of 180 degrees. And so I'm going to subtract off the 83 and subtract off the 59. So let's go ahead and do that. So let's see, oops. 180, take off 83, and then take off 59. And that'll leave us with 38. So that's what this is going to be. This is going to be 38 degrees right there, okay? Okay, so then looking at my angle C right here, if I were to draw my north and south pole right there, like basically it's just parallel with these other lines that I have here, okay? And so what's going on here is, see, if you were to kind of continue this out, what's going on here is I have alternate interior angles again. We saw that on the previous problem. So that would make this 59 degrees. And then I have the same thing right here. This angle, the angle that's created inside these parallel lines right here, alternate interior. So this one would be 39 degrees. And so I'm sorry, 31 degrees. So together, that's going to give us 90 degrees. So that's going to be a right angle. That's going to be a right angle right there. Okay. So then I can figure out my other angle right here, because the other two angles add up to 90. So let's see, what would that be? 52 degrees right there. So you can see my drawing is obviously not perfectly to scale, but it's not too bad. Okay, so now let's see, what are they asking for? They're asking for the distance from A to C. So we want to figure out this distance right here. We want to figure out this distance right here. Okay. Now, I have to know at least one side, and then we can use one of our trigonometric ratios. And so they do tell me that the plane flies 250 miles at 2.8 hours from A to B. So I can figure out the distance from A to B pretty easy right here, just multiplying that together. So we'll do that. So 2.8 times 250. So that's going to be 700. So that's what this is going to be. This is going to be 700 right here. Okay. So there's, quite a few different ways you can do this. So you just have to pick one of your ratios and go with it. And you got to pick one of the acute angles. And so I'll go from angle A. And so what I'm going to do from angle A, let's see, that would be if I need to do if I want to do adjacent over hypotenuse, because the hypotenuse is the 700, I'd have to do cosine. So cosine of my angle, angle A right there, which is 38 degrees. It's going to be adjacent. That's going to be my unknown. That's going to be my unknown, so we'll call it x. That would be adjacent over hypotenuse, which we figured out was 700. And so then from here, we'll multiply both sides by 700. And so we'll end up with x equals 700 times cosine of 38. So let's go ahead and do that. Let me make sure I'm in degrees. Okay, good. So let's see, 700 times cosine of 38. And so I'm getting 551.6. So 551.6 miles. Once again, I'm not sure what your, let's see what it says. It says round to the nearest integer. So if we were going to round, that'd be 552 miles right there. Okay? Hope that helps.